So good morning everyone. As you all know that we have completed our fourth unit, which is related to your triangulation surveying and least square methods errors. The next chapter we are going to start is your photogrammetric surveying. Okay, so in this basically photogrammetric surveying, by its name it indicates that in this we are going to do surveying with the help of photographs. So photographic surveying or photogrammetry, it is also called as photogrammetry, or you can say it is photogrammetric surveying. Okay, it's a science and art of obtaining accurate measurement by using photographs. So basically what you are going to do is that with the help of photograph we are basically doing some measurements, and with the help of photograph we can find out whether how much distance is there between 2 points or any other thing if you want to find out with the help of photograph for various purposes such as construction of planimetric and topographic map. So it is used for a variety of purpose, that is planimetric and topographical map. It is also used for classification of soils, that which kind of soils are present at different ground. And the next is your interpretation of geology, how is the geology available in that particular area, that can be acquired through photogrammetric surveying. Acquisition of military intelligence, so it is very important. This is for military intelligence purposes. Photogrammetric surveying is very important for that. Generally photographs are taken with the help of some your planes. Okay, and that can be very useful for military purpose. And the preparation of composite picture of the ground, and it is also used for composite picture of the ground. So basically photogrammetric surveying, in this what you are doing, you are taking photographs. Okay, and with the help of photographs we do certain measurements, and with the help of photograph we try to find out the distance or any other things from that photograph. It is used in a variety of purpose, such as for topographical map, it is used for classification of soil, like interpretation of geology, military intelligence purpose, and so on. Now the photographs are either taken from air or from the station on the ground. So in this there are two cases. The photograph might be taken from the air, okay, or from a station on the ground. Okay, so tertiary photogrammetry is the branch of photogrammetry where photographs are taken from the fixed position. So if it is taken from the ground, okay, so if it is taken from the station on the ground, then it is called as tertiary photogrammetry. Okay, and if it is taken from air, it is called as aerial photogrammetry. Okay, tertiary photogrammetry is a branch of photogrammetry where photographies are taken from the fixed position on near the ground. Aerial photogrammetry is the branch of photogrammetry where the photographs are taken by the camera mounted in the aircraft flying over the area. Okay, so this is the two classification of photogrammetric surveying. One is your tertiary photogrammetric surveying, and second is your aerial photogrammetric surveying. Okay, mapping of from aerial photogrammetry is the best mapping procedure yet developed for a large project. So for large project, as you all know that we need to cover areas in kilometers, so it is very useful and it is very handy also that we can use your photogrammetric surveying. Okay, because your plane require very less time to travel the distance. Okay, so it will help, or somewhat is considered to be the best for mapping what in order to, if you are doing surveying for large projects. Okay, and it is very invaluable for your military intelligence, and it is very useful for intelligence purpose. Okay, so this is a small introduction part of your photogrammetric survey. So let us discuss a little bit about tertiary photography. Basically the principle of tertiary photography was improved upon and perfected by Captain Deville, the Surveyor General of Canada, in 1888. Okay, so basically once it was evolved, it was being improved by Captain Deville, and which was a Surveyor General of Canada in the year 1888. In tertiary photography, photographs are taken with the camera supported on the ground, as I've told you in the first slide also. The photographs are taken by means of phototherapy. So the instrument which has been used over here, it is called as your phototherapy. Basically it is a combination of what your camera and your theodolite. Okay, that is why it is given called as your phototherapy. Maps are been compiled from the photographs. Now with the help of that photographs, we will compile your map. Okay, so this is your tertiary photography. The principle underlying the method of tertiary photogrammetry is exactly similar to that of plane table surveying. The procedures and your principle on it is similar to that of your plane table surveying. If The direction of the same object photographed from two extremes of its measure has been shown. Their position can be located by the intersection of the two rays on the same object. However, the difference between these plane of tabling is that more details are at once obtained from photographs and their subsequent plotting etc. is be done by the office, while the plane tabling all the detailing is been done on the field. So basically what you have to do is that we have to select a baseline, and on this point you will have to establish your camera, and this point you have to establish your camera, and at certain angles you will take photographs. Okay, and with the help of these photographs you can find out different points on this particular area. Okay, this is about your tertiary photography. Okay, so the photothodolite is nothing but an instrument which is a combination of what 1 second theodolite. Okay, and it is consisting of a camera and a tertiary camera. Basically that is the only thing you need to remember about this, that in this tertiary photogrammetry you will use photothodolite, and the photothodolite consists of your theodolite of 1 second. Okay, 1 second means what, it is capable of measuring an angle of about 1 degree also, or 1 second also. Okay, and a tertiary camera. Okay, now in aerial photogrammetry, first we need to understand what type of camera has been used. Okay, so the primary function of your tertiary camera as well as your aerial camera is the same, obviously, because both are taking photographs, so the primary function becomes same. Okay, however, since the aerial camera is mounted on the fast moving plane, so as you know that aerial photogrammetric surveying is done with the help of camera, which is generally mounted on the planes. Okay, so when the plane moves, it start collecting photographs. Okay, so the requirements are quite different. Okay, obviously if it has been using on a moving plane, aeroplane, its requirement will be different. The aerial camera require fast lens. Okay, it should consist of a fast lens, high speed and efficient shutter. Okay, the next is your high speed emulsion of film. Okay, the magazine to hold large roll of film. Okay, and you can see over here there is a diagram of this aerial photo camera. Okay, the first point, it is called as the magazine. This entire rectangular box is considered to be a magazine. Okay, the second point is called as the focal plane. Okay, third one, it is the body of your camera. Okay, next fourth one is called as the terrarium. Next one, fifth is your cone. This is your conical part. Sixth is your lens is over here. Then 7 is shutter, so shutter is when over here. This is the shutter of your camera. 8th is your diaphragm. Okay, it consists of your diaphragm just below your shutter. And 9 is your filter. Okay, 9 is your filter. So this is the whole assembly of your aerial camera. Okay, I think this much is sufficient for the introductory part of your photogrammetric surveying, which is divided into two categories, that is your tertiary photogrammetric surveying and your aerial photogrammetric surveying. Okay, now some definitions and nomenclature related to your photogrammetric surveying, which is required while studying your photogrammetric surveying. One is your vertical photograph. So the vertical photograph is an aerial photograph made with the camera axis coinciding with the direction of gravity. So if it has been suppose this is your vertical plane and the camera has been kept in this way, and the ground is facing this side, so it is facing the gravity in the vertical direction. So this is a vertical photograph. Tilted photograph is what? A tilted photograph is an aerial photograph made with the camera axis unintentionally tilted from the vertical by a small amount, by less than of 3 degree. So what you have to do, that you are not perfectly keeping it vertical, but you have to tilt it to a certain angle. That is why it is called as your tilted photography. Then is your oblique photography. And oblique photography is an aerial photograph taken with the camera axis directly intentionally between the horizontal and vertical. It is apparently if the apparent is horizon is shown in the photograph, it is said to be high oblique. If the apparent horizon is not shown, then it is called as low oblique. So basically what you are doing, you are keeping in between what, somewhat between your vertical axis and your horizontal axis, and such type of photograph is included in your oblique photograph. And if the photograph is showing your visible horizon, then it is called as your high oblique. If it is not showing your visible horizon, then it is called as your low oblique. After that, the next term which is important is the scale of a vertical photograph. As you all know that uh, photographs are being taken, and we need to convert that 2 points on the photograph in terms of the distance which has been actually on the ground. So for that we require the scale of the photograph, and the scale of the photograph is given by the formula small f by capital H minus h. Okay, where you can see that where h is the height of the exposure station. So you can see that this is total height from where your photograph has been taken, is called as the capital H, which is above the mean sea level. F is the focal length of the camera, and small f has been given by the focal length of the camera, and h is the height of the ground above the mean sea level. Okay, so suppose this is the ground, and this height from the mean sea level is given by small h. So with the help of these terms we can find out the scale of your photograph. Okay, again, scale of photograph, scale of vertical photograph. Why it is important? Because in photogrammetric surveying you are taking photographs, and with the help of photographs you are trying to determine the distance or the elevation of different points on the ground. So that you need to find out the scale of the photograph, and according to that you will have to convert it into your actual ground measurement, actual ground elevation. Okay, so for that you require the scale of the map, and it is given by the formula small f by capital H minus or your small h, where f is the focal length of the camera, h capital H is the height of the exposure station from the mean sea level, and small h is the height of ground from the mean sea level. Okay, we will also do some numericals related to scale of photograph, and that you will understand how it has been calculated, your scale of photograph. And one more thing, the computation of your length of a line between points or different elevation from the measurement of a vertical photograph. So if you have been provided with a photograph, how to calculate what the length of the line of different elevation from the measured vertical photograph. So and there is a derivation regarding this, and with the help of this we can calculate the length as well as the elevation also. Okay, so you will have to understand this. Let A and B be the two ground points having an elevation of HA and HB above the datum. So as you can see that there is 2 points on the ground. One is your point A, one is your point B, which is at a certain elevation from the mean sea level. It is having a height of HA, and it is having a height of HB. And the coordinates, and if you try to calculate the coordinates, suppose this is your origin, and if you try to calculate the origin coordinates are, this will be your XA. So from this origin, okay, this is XA, this is your YA, for this is the coordinate for your point A, and this is the coordinate XB and YB for your next point, that is your point B, respectively, with the respect to the ground coordinates axis which coincides in the direction with the photograph coordinates X and Y. The origins of the ground coordinates lies vertically beneath the exposure station. So you can see that the same thing has been plotted on the ground surface also. This is the point B with the coordinate X. Okay, this is XB, this is YB, and this is XA, and this is YB. Okay, and the exposure of your camera has been somewhere here. Let A and B the corresponding point of the photograph, and XA and XA, YA and XB, small XA, YA, and small XB and YB be corresponding coordinates from the similarity of triangles. So we will try to apply similarity of triangles between these triangles. So you can see that. Okay, so you can see that there is a triangle formed, and this type of triangle has been formed. Okay, so you can see that there is a triangle form over here. First we are taking A coordinates only. Okay, so this is a triangle, first triangle. So XA, this small XA divided with by this capital XA. Okay, these are two triangles. This small XA, this is capital XA, equals to what? And in the similar manner, this YA will be equal to this small y. Okay, uh, which can be written as what your focal length formula, which can be given by a focal length formula f equals to what, capital H minus small h. Okay, and similarly in this case also B, there is another triangle. Okay, this is one triangle, this xb, small xb divided by capital xb, and this yb, small yb divided by capital yb. It can be again given by the your focal length formula. Okay, so we have got this first equation and second equation. Hence we have what, because x equals to what, from here if you want to calculate the actual ground position on the earth surface, it can be given by what, x equals to what, capital H minus small h. Okay, since you are taking this term on the upper side, so this will be on the numerator side, so h minus capital H a divided by f into xa. Okay, now similarly your y, it can be given by capital H minus small h a divided by f into your y, and similarly your xb and your yb. Okay, in this way you can calculate the coordinates, and with the help of coordinates we can find out the elevation as well as the length. So in general, coordinate x and y, the point on elevation can be given by the formula x equals to what, capital H minus small h by f into x, and y equals to what, capital H minus small h by f into y. And if you have to calculate the length of the line between 2 points a and b, it can be given by formula L equals to what, capital xa minus xb the whole square plus ya minus yb the whole square. With the help of this we can also calculate the length as well as the elevation of the ground point which has been present, okay, with the help of this photographs. Okay, so the next term is related to a relief displacement in a vertical photograph. So in order to understand relief photograph, you will have to understand this theoretical part, that we have seen that if the photograph is truly vertical, then the ground is horizontal, and if other sources of error are neglected, the scale of the photograph will be uniform. So what it is saying, that if the photograph has been truly vertical and the ground is perfectly horizontal and there is no sources of errors, and sources of errors are all neglected, then the scale will have a uniform scale. The photograph will have a uniform scale. That it is saying that such photograph represented true orthographic projection. So such photographs are called as true orthographic projection, and hence true map of the terrain. Okay, so whatever map will be prepared, that will be called as a true map. But in actual practice this will not happen, because whenever you are taking photograph, you will see that the ground is not always perfectly horizontal. So in that case, the scale of the map, the scale of your photograph will continuously change. Okay, and since the photograph is a perspective view, the ground relief is shown in perspective on the photograph. Every point on the photograph is therefore displaced from their true orthographic position. This displacement is called as relief displacement. So whatever point we are getting on the photograph will not be exactly at that particular place because of the relief displacement, because the ground is not perfectly horizontal. Okay, that is why the amount which has been getting displaced is called as the displacement. Okay, in order to understand that, you will have to understand this diagram. Over here there is a photograph, there is a camera provided over here. Okay, and the line which has been represented is represented by KO line. Okay, this is your tower. Suppose you're taking a measurement of this tower. Okay, this is the topmost point of the tower, capital A, and this is the bottommost part of the tower, which is capital AO. Okay, this is distance R actually on the ground, and you will see that though these 2 points are lying on the same particular line, okay, but this will be represented on the photograph in two different positions. Okay, one is your capital A, one is your AO point. Okay, so this point is called as your, so the difference is this only. Okay, so this is your line which is being represented by capital A, small a, and this line is represented by small a. So there you can see that there is two line representing this. R is the radial distance between A and K. So this is suppose the line K. So this is AK line, and RO will be the radial distance between AO and K. AO and K. So you can see that there is this two lines should be on a straight line. they should not be differ from each other. So this displacement, the amount by which this has been displaced, is called as your relief displacement. Okay, sometimes it is required to calculate this relief displacement. Okay, and capital R is given by what? KO into your AO. Then by using similarity of triangles, F equals to what? Capital H by small h equals to what? R by R. Okay, so the scale formula, F equals to what? Capital H minus small h. This height by your focal length equals to what? R by capital R, from which the equation number 1, if you have to calculate R only, the formula will become R into F by capital H minus h. Okay, this is the first equation. Also for your RO, this will be equal to what? And in case of relative displacement, this height F by what? Total capital H, okay, into what? RO by capital R. So RO equals to what? RF by R into F by H. Okay, so we have got two equations for this, and hence the relief displacement is given by this. So as I've told you, the difference between your small r and RO will be your relief displacement. So R has been given by RF into capital H minus H minus what? RF into capital H, which is your RO. So with the help of this, you are taking the upper terms as common. So RF will be common in both the cases. Okay, or you can cross multiply these two equations. So you get the final equation as RF into H by capital H into capital H minus small h. So after doing a calculation, okay, if you want to find out R, but if we know that this value R is given by small r into capital H minus h into F. Okay, so we can replace this, we can put this in your this equation, and you will get your new equation, and the relative displacement formula becomes what? RO into H into capital H minus H. Okay, so we will use this formula. Okay, and sometimes also required to find out the height of the object from relative displacement. So the scale formula is F by capital H, and H is given by DH into R. Okay, so once we are going to start with the numerical, we will try to understand how it has been done. So the first numerical related to your photogrammetric surveying is your vertical photograph has been taken from an altitude of 1200 meter above the mean sea level. Determine the scale of the photograph for a terrain lying at an elevation of 80 meter and 300 meter if the focal length of the camera is 15 centimeters. So what we have to do is that we have to find out, determine the scale of the photograph. So the scale of the photograph has been given by the formula SH equals to what? F into capital H minus small h, where F is the focal length, capital H is the height of the exposure station, and H is the height of the ground above the mean sea level. Okay, so the terrain height elevation is 80 meters, so small h is equals to what? 80 meter. Okay, and then 300 meter above, and 300 meter is the focal length, so this is your capital H. Okay, sorry, the vertical photograph, sorry, this is the capital H. This height was, the total height of the photograph was 1200 meters, so 1200, so F we have got 15 centimeters, so 15 divided by what? 1200 into 80, that will give you 1 centimeter by 74.67 meter. So that represent that if there is 1 centimeter, if you draw on your photograph, that indicates it is total distance of about 74.67 meter. Okay, then anything else it was required or what? These all things are not required, only you have to do this much only, that you have to apply the your scale formula, and with the help of scale formula try to calculate what is the scale of your map. Okay, the next one is a camera having a focal length of 20 centimeter is used to take a vertical photograph of an average elevation of 1500 meter. What is the height above the mean sea level at which the aircraft must fly in order to get the scale of 1:800? So in this it is a little bit tricky type of question. In this, what you have to do is that you have to find out what the height of the camera at which the scale will come out to be what, 1:800. So the scale is expressed as RF equals to what, F by capital H into H. This is your refraction factor problem, or you can directly use this formula. SH equals to what, F into H minus, but here you have got the value of scale, which is 1 in 8,000. Okay, equals to what, we have got the F value as 20 centimeter. Okay, so but then condition for this is that you are trying to calculate the height, so you will have to convert this into in terms of meter. Okay, so 20 by 100 into your capital H is required minus your F value. F value is what, 1500 meter. So the final value of H is coming out to be what, 3100 meter above the mean sea level. Now the next problem is related to 2-point problem that we have done the derivation for that. 2 points A and B having an elevation of 500 meter and 300 meter respectively. Above the datum appears on a vertical photograph having a focal length of 20 centimeter and a flying altitude of 2500 meter above the mean sea level. The corrected photographic coordinates, we have got the ordinate x equals to what, plus 265 minus 192, y equals to positive 1.36 and positive 3.65. Determine the length of the ground line AB. So what we have to do, we have to calculate the length of the line. So we have calculated this in the derivation that we have to first calculate what XA equals to what, capital H minus small h a and divide by F into XA. Here we have got all the value. We have got the H value, it is moving at an altitude of 2500 above the datum. Small h a, the height is of point A is what, 500 meter, divided by F. F is the focal length, which is 20 centimeter, and XA we have got plus 2.65. So the value is coming out to be positive 265 in case of capital XA. And similarly YA HA into small HA, H minus small HA by F into Y, so 2500. And again height A value, elevation of A is 520, so this is coming out to be 136. And similarly XB and YB, so which is coming out to be minus 112.2 and positive 101.5. Okay, so after this we will try to calculate what we will use this. In order to calculate the distance, we have to use this formula, XA minus XB the whole square plus Y minus YB the whole square. So XA minus XB is coming out to be this value, and then Y minus YB the whole square is coming out to be this value. And if you underroot these two terms, you will get the value as 545. So actually on the ground the total distance between A and B is 545. Okay, there are other numericals also related to this, but I'm not sure that this type of question will be asked in your university exam. So I will finish your photogrammetric surveying over here only. Okay, this is all related to your photogrammetric surveying. Thank you so much.